Hello, Assalamu alaikum. I am Ishrat Jahan Eisha and this is our line follower robot, and I am going to explain the environment setup part and how we made the robot. But first, I would like to apologize for the noise. My laptop is troubling a bit. However, starting with the rectangular arena, we played with some designs and gave it a floor and directional lights and some objects. We kept it simple, and so we used less objects. We scribbled the pathway from the Timka for our robot and imported the object file here. The robot we made will have to follow the pathway here. For the robot, we followed the same process and we did in project 1. We made the robot body and attached moving wheels, and for that we used hinge joint and rotational motor. We also used we also we fixed the appearance and color as desired, and also added bounding object and physics to it. So we also added distance sensors in the place of IR sensor that will work as as IR sensor, and we also gave a camera and the time step in it to give us updated images with the time set accordingly. This is how we set up the environment, and next we will work on the code part.
Hello, Assalamu alaikum. I am Fatima Tabassum and I will explain the code part of our project 2, that is the code of our line follower robot. Firstly, the robot and camera library was imported here along with defining the time step value that will actually give us the updates according to the time that we set. Then we take the wheels in an array, naming them to be the same as the rotational motor. We used our IR sensors from taking the distance sensor, keeping the names identical left, mid, and right to avoid any sort of errors. After this, we all mark the errors by taking the readings of the sensor, that is ranging from -2 to 2. Here, each value indicates if the robot is following the line or is deviating. -2 means that only the right sensor is on the black part and there is complete error since the robot is deviating from the chosen path. -1 means right and mid sensors are on the black part and there is minor error. 0 means that the mid sensor is on the black part, and this same goes for the other side, that is 1, 2 also, the positive side. To minimize these errors, we use PID, that stands for proportional integral derivative. PID actually implies to be a feedback control system, and from using the value of the error, we can calculate the value of PID. We know that motor power is proportional to error. So therefore, if we have a small error, the motor speed would decrease, and if we have a greater error, the speed would increase. We keep some constants, Kp, Ki, and Kd, for calculating the balance. Our aim with PID is to calculate how much the robot is deviating from its path, and we adjust the speed of the wheels from that very calculation. The balance is serving as our adjustment value here, as in how much we need to adjust. We calculate the left and the right speed using the balance and max. In here, the speed comparison is done, that actually checks and satisfies all the error that are caused, and finally assigns the speed of the wheels according to the calculation. So basically, if we are having any sort of error, that error is calculated, and according to that, the motor speed is adjusted and the wheels are moved forward. And if we say that the error is equal to 0, that means PID and balance is also equal to 0, and it means that the left speed and the right speed stays the same, and all the wheels get the same forward speed. So this is how the PID helps us minimize errors and adjust the speed of the wheels according to those error calculations. Thank you.
Assalamu alaikum, MD Alkawser Rahman here. Firstly, let's start by summarizing our line follower robot project quickly, and then we will simulate the project for better understanding, where we will be able to see how our robot performs by moving around the track and following the line without getting interrupted. As mentioned earlier, we have programmed this particular robot with the proportional integral derivatives or PID control system, which makes it possible for the robot to follow a track by generating a control loop feedback using the data from the sensor in order to stay in line with the path. Now let's press the play button to simulate. After pressing the play button, we can see that the robot uses the PID and the IR sensor in front of it to follow the predetermined track to maneuver along the area through the path we have set before. Also in the sensor data console, we can observe how the robot is taking data input and adjusting its speed and movements accordingly in order to make sure it doesn't fall out of the track. Therefore, if we will fast forward the simulation, we can see that the robot will keep on moving on the track without causing any error. Finally, we can say that if we ran the simulation for a long time, the robot will never go out of the track and perform flawlessly. And that's all from our project. Thank you very much for listening patiently.